Understanding a journal publication in under 3 minutes. In this video, we're going to be explaining to you the paper, An Artificial Finger Robot Motion Control Based on Finger Joint Angle Estimation from EMG Signals for a Robot Prosthetic Hand. Wow, that's a mouthful.
So what's it all about?
Researchers from Japan designed a robot finger. They used EMG signals to find the joint angle estimation, and then used a PID controller to control the finger. EMG stands for electromyography, or in other words, nerve signals.
To measure EMG signals, disposable electrodes for an electrocardiogram were used.
This finger's joint angle is determined by a tension balance between a flexor muscle and an extensor muscle. Surface EMG electrodes were applied to the muscle tail of the superficial flexor of the digits and the muscle belly of the common digital extensor muscle.
EMG signals measured by electrodes were amplified and bandpass filtered between 10 to 15 kHz, with a biosignal amplifier recorded with a sampling frequency of 10 kHz.
Taking this data, and this big equation, they could determine the angle that the robot finger needed to go to. So how does our robot get to the right position? Well, it uses a PID controller. PID controllers, which stand for Proportional Integral Derivative Control, is the most common control algorithm used in the industry. The basic idea behind a PID controller is to read a sensor, then compute the desired actuator output by calculating proportional, integral, and derivative responses, and summing those three components to compute the output.
To compare the robot system's finger joint angle estimation done with these electrodes, the angles of the finger joint were also measured with the commercially available Cyber Glove.
And now the results. The solid line indicates the actual measured finger joint angles, while the dashed line is the angle estimated by the method and surface EMG signals.
The estimated joint angle obtained by their method is very close to the measurement angle.
The result indicates that the system used in this experiment is technically feasible for an application to a real prosthetic hand system.